Hi, I'm Graham Roberts. Welcome to this second video in the introduction to linked lists using CPP, that is C++. Okay, in the first video I showed that linked lists are really all around us all day, every day, even when we alphabetize a list of names, for example. And we're going to have a pre-sorted list of names here. But this is only because I want to show how the list links rather than how you manipulate the linked list. The first thing to note is that we've included the IO stream and the string headers, and we're using a namespace of standard. I'm not going to comment on that, that's really about CPP. Here though we've got a struct or a data structure called a node, and it's got a name string and it's got a pointer to the next node called next. So it's got that setup we saw in the first video of a pointer or a reference to the next node in a sequence, or to 0 or to null to terminate the sequence. We have to have a main function, which we've got here, and I set up a string called name, and I set the first node, which is called head, because it's always going to be there. This is the first node looking at the very first entry into the linked list, or to null if the list is empty. The head is set to a new node, so some memory is taken up to have a node at all that we can put data into. Then we put some data into the name part of the node, the data part or datum part, and then we set the next, that's the pointer, to null, that's to 0. Now if we output, we should see Andy as the name part of the head node. C in get here just holds the console output for us to see. So if we run this, what we should get is Andy, as we do. Right, I'm just going to clear this over here because we don't really need that at the moment. Well, in fact, I'll just close it there. And we're going to make this a little bit more complicated. Now we've got rid of the output, we don't need that anymore, and I'm going to set up a new node called tracker. Now really this tracker is the tail. It's always pointing when it's finished. It travels at the end of the sequence. The reason it tracks through the sequence from the start to the finish is so that we can put the next datum or node onto the end of the list. So we start from the head of the list and we add to the tail of the list, always at the end of the list. That's the idea here. So the end of the list will have a node that points its next to 0 or null, but the data in it will be the very last data in the list. So we set node to point we set tracker to point to a node we created, and we set the tracker to point to the head because we want it to travel from the head down. We don't want to do this if the tracker is already null itself, but if it isn't, we can loop through. So while the tracker next doesn't equal 0, we set tracker to the next tracker next. Now that sounds complicated, but actually it just goes down the list. If you imagine the list was, say, a train, and you start at the engine, which is the head, then you can travel through the different carriages on the train, and right at the end you'll find the guard's van, which tells you you're at the end of the train. Then what you're doing is walking through the train, carriage to carriage to carriage, in this loop until you get to the guard's van. Well, if we want to add another carriage, we get to the guard's van and then we uncouple and put in another node just there, just before the guard's van. And so we need to say that tracker next is going to be created as a new node. It's a new node because we want to actually put some data into it, and we want to make a new carriage, if it were in the illustration. Then we set tracker to tracker next to point to that node, and then we set tracker next to 0. We set it to 0 because we want this node to be the last data entry in the list. So we need to, as it were, reset the guard's van. We need to put some data in, so I've put in the name of Beth. Then we set the tracker to the head, because remember we're going to start again from the head of the train and move all the way down through the train to the guard's van, as before. So when we get down to the end, when tracker next is equal to 0, we'll be at the end. And why have I done that? Well, because I'm going to add another node. If I'm going too fast, don't hesitate to use the pause button and rewind. It really is vital to understand how important it is to get to the end of the list before you add something to it when you insert at the end. The tracker, as I'm calling it, which is really the tail at the end of the day, or the guard's van, the tracker is set to the head and it's got to the end, hasn't it? So now we can insert a new node just as before. In fact, these were copy and pasted, and I just changed the name to Kathy in this case. And then I'm going to put in Daniel. Just copy and paste again. Now this last time here we're going to print them all out. Because the tracker has got to the end, or the tail is pointing to Daniel, we can in fact print out all the names that are in there. We're going to do exactly the same thing as before. We're going to set the tracker to the head. Remember that head node is still existent, and we're going to move through until we find a 0 in the link, and we're going to output the tracker name with a new line. That's a new line indicator. Let's run it and see what we get. We get Andy, Beth, Kathy and Daniel, which in fact were the 4 names that I put in to the linked list. Let's just recap. In this C++ program, we set up the handling of input and output to the console and strings. We set up a shorthand way of referencing the standard input-output here, the namespace. We set up a struct node where the datum is name and the reference is next, which points to another node. It can hold the address of a node. The main program, which is what runs, sets up a name, which is of course string, and it sets up an unchanging first node, which is the head in this case. And the head is created, so their memory is created. Then the head datum value of name is assigned. We could get this from the inputs using cin, getLine or getString. We could actually get the name from there, but we've done this for simplicity, just assign the value. Then we say that the reference to head is 0, because every linked list must have a start and a finish. It must have a head and a tail. In this case, the head is both the head and the tail. because there's only one node, and that is the head node that happens to have Andy as its datum value. Then we set up a tracker, which, if this was in fact a train, would be something like a conductor moving through the carriages, going from the head, the engine, to the guard's van at the end of the train, through the carriages. I've called him a tracker here because it's tracking through the linked list from the head to what will be the tail. There is always a tail, a finish to the linked list, which is either pointing to null or to 0. After we've created the tracker node, we set the tracker to the head because, well, that's the start. Then we go through, see line 24 there, we go through in a loop which ends when we reach the 0 value for the reference of next, or null. Otherwise, we track through and we point to the next in the sequence, the next node. When we are sure we are at the end, we can create another new node and set that, the address of that, to be in the last node's next reference. Then we can set the tracker to that node and set its next value to 0. We can set up a datum entry of Beth. We can then set tracker back to head because we want to go from the head to the tail to make sure we're at the tail of the linked list. Why? Because we're going to add another datum node to it. We wouldn't need to do that if we were not adding another datum node. So we create another node, and the whole thing is repeated except for the datum value. And of course you'll be thinking, well, we could use routines for this, functions, and of course one does. If you ever look at linked lists that are implemented, they will be much more sophisticated with functions to do what we are doing in a sequence. They will have functions to be called to be able to generalize and do things generally rather than specifically like this. We're being very explicit. And then Daniel is added, and right at the very end we track through from the head to the tail again, but this time we're not adding anymore. We're just wanting to see what we've already added. We want to print out the linked list. To print it out, we start from the head of the linked list and go to the tail, which will be where 0 is the value of the final reference. What this has tried to show is that linked lists are, at first face, simple. Then when you come to the code, at first face they look complicated. And the reason they look complicated is because one is talking about nodes and pointers and referencing, and to get the data entry in, you have to create a new node and so on. But essentially one is going from the head to the tail of like a snake, or from the engine to the guard's van of a train of carriages. And because it's always the same, that one is always tracking through from the head to the tail, it actually, once you've worked out one way of doing it, that you can do that way as often as you like using routines, and that what it appears at first complicated isn't in fact complicated to use. And it turns out that it is so efficient and effective that nearly all of the data structures we commonly use and rely on are essentially linked lists. I hope this has been helpful.